Hi, kids. Here we go one more time. Not one last time, one more time. We're going to talk today about what's called the percent composition by mass. You're going to have a calculator and you're going to need your periodic table. Okay, so up on top is a blueberry tart. Blueberry tarts are fun to eat. It's a nice picture. The blueberry tart is made of blueberries. How much blueberries? All blueberries. 100% blueberries. Blueberries are fun to eat, but when you have just a blueberry tart, you can't do any math on it. What percent of the blueberries are blueberries? 100%. That makes it kind of, Now, look at this fancy one on the bottom. The one on the bottom, because I say so, is made up of 8 ounces of strawberries, 3 ounces of kiwis. 8 ounces of strawberries, 3 ounces of blueberries, and 5 ounces of kiwis. It's 16 ounces, 1 pound altogether. We can do math on that, right? Watch what we're going to do. Out of the 16 ounces total, strawberries make up 8/16, 8 ounces out of 16 ounces of the whole amount. Now, what percent of that is strawberries? You can do this right in your head. 8 divided by 16, 50%, right? This fruit tart makes my mouth water. It looks so good. Since it's 8 ounces of strawberries out of a total of 16 ounces of fruit, 8 divided by 16 times 100%, that's 50%. You can do that right in your head. What about blueberries? Blueberries, 3 out of 16. Now, a little hard to do in your head, right? But 3 divided by 16 times 100%, that's equal to 19%, right? Here, let me get my calculator, and I will show you exactly how to do that. 3 divided by 16 equals times 100 equals, can you see that? 18.75, which I rounded to 19. Now the last part, the rest of it, right, there's no more, it's just these 3 fruits, right, that make up 100%, would be 5 out of 16 times 100%, that's 31%. So half of the fruit, 50% is strawberries, and 3 out of 16 ounces is 19% blueberries, and 5 out of 16 ounces times 100% 31. And guess what? It equals up 100%. How cool is that? The sum of the parts is equal to the whole fruit tart, right? 16 ounces of fruit, 50% strawberry, 19% blueberries, 31% kiwis, adds up to 100%. This is called what is the percent composition by mass. Not by size, not by color, not by this, not by that, but by mass. We have to do the mathematics of the grams of the part that we're looking at divided by the total grams times 100%. And guess what? This class is not called Fruit Tarts 101, it's called Chemistry 101. Chemistry means we could do this on chemical compounds as well. So the first question in what's called percent composition by mass is how do we determine the percent composition by mass of hydrogen and oxygen in water? Now, water is H2O, 2 hydrogens, 1 oxygen, 2 atoms of hydrogen, 1 atom of oxygen. How do we figure out the molar mass? Well, you draw the formula, draw a line, list the H to O, and you plug it in. Now, this is quick, right? You already knew how to do this. There's 2 hydrogens, they're each 1 gram, 2 grams for hydrogen. There's only 1 oxygen, it's 16 grams, 16 grams, and then you total it up, and we get 18 grams per mole. Now, this is a number you should keep in your head. Water, we're going to see all the time. Water is going to come up a lot. What is the molar mass for water? 18 grams for water, 18 grams per mole. If you have 18 grams of water, holy cow, then that's going to be a whole mole. Let me see what my can says. I'm drinking a brand new can of seltzer. I don't know if it says how many mLs this is. I know it's 12 ounces. I don't see that. Well, I'm not going to figure it out. Anyway, 1 ml of water is equal to 1 gram. All right, so this can is, I'm going to guess, I don't know. It's more than 180. It's more than 10 moles of water. Okay, now the percent composition by mass. On the right side, I'm going to finally use the right side of the page. This is what we're going to do. On the right side of the page, we're going to write this, percent comp by mass, and we're going to do it in the same order. We're going to do hydrogen and oxygen. And they're a little further apart because it's a bigger formula. It's not just a straight little line. It's a little bigger. But H and O, we're going to do the percent of water that's hydrogen by mass and the percent that's oxygen. Now, just like the fruit tart, how many ounces were strawberries out of the whole? How many grams are hydrogen out of the whole? Times 100%. So here we go. First one, 2 grams of hydrogen out of 18 grams total times 100%. All right, let's get our calculators. Hit the clear button, and we have 2 divided by 18 equals times 100 equals, and I get, can you see it? 11.11111111. I rounded that to 11%. So if you have water, the mass of water, 11% of the mass is hydrogen. How much is oxygen? Well, it's the rest, right? But here we go. Oxygen makes up 16 grams out of the 18 grams. All right? The part that's oxygen is the 16 out of the whole 18 times 100%. And the calculator will show you that it's going to be 89%. You know what's most important here? If you add it up, it comes to 100%, right? There's only hydrogen and only oxygen. It has to come up to 100%. Mathematically, that's your check. Because if it comes up to 111% or 117% or 84%, that means you did something stupid, right? You got to fix that. Got to equal 100%. This is called the percent composition by mass. Water is 11% hydrogen and 89% oxygen. Doesn't matter how much you have. One drop, 11% of that drop's mass is hydrogen, and 89% of that drop would be oxygen. A swimming pool in my yard, right? Filled up with water. The water part, I mean, there's some other stuff in there, right? There's some leaves, there's some dust, there's some chemicals. But out of the water, 11% of the water is hydrogen and 89% is oxygen. Now, what does that mean? That means if you had 100 grams, here's one more in red. If you had 100 grams of water, 11 grams of hydrogen and 89 grams of oxygen. Those percentages are exact for any volume or any mass of water. Doesn't matter how much you have. Water is water, and it's 11% by mass hydrogen and 89% mass by oxygen. Now, what is the percent composition by mass of sodium and chlorine? My wife just waved to me. She loves me. Of sodium and chlorine in sodium chloride. So we're going to do the molar mass on the left. Go ahead, you do this. I'm going to take some salsa. I'm going to drink a mole of water. I just drank 6.02 times 10 to the 23rd molecules. 1 mole, exact. 18 grams down the hatch. Okay. Sodium chloride. List them. Sodium and chlorine. Sodium is 23 grams. Chlorine's 35. There's 1 of each. 58 grams per mole. The molar mass of sodium chloride is 58 grams. Now, the percent composition by mass. What part is sodium by mass? What percent or part? What part or percent is chlorine? So, of course, the sodium is 23 grams out of 58 grams. 23 is the sodium, and the total is 58. The part divided by the whole times 100% equals that. And maybe you want to say 40%. This time I said 39.6. It's all unlimited significant figures. You round any way you feel like it. The next one, chlorine. Chlorine is 35 grams divided by 58 times 100%. Now look what happens when we add this up. Are we okay with this? 99.9? Yeah, we are. You know what? If I made it 40% and 60%, it would have been closer, right? But it would have been rounded. These numbers are really, really close. For our purposes in class, 99.9, if you're off by more than, say, 0.2, say 99.8 to 100.2, if you're close, you're good, right? The difference is lost in the decimals, but you're close enough. This is not exact. If you really want exact, round it to 40% and 60%. That'll give you 100, but 99.9, that's close enough. For what we're doing, it's all good. Now, this compound, copper Roman numeral 2 sulfate, CuSO4. What is the percent that's copper? What is the percent that's sulfur? And what is the percent that's oxygen? I give you a moment. You should hit pause. I'm not going to wait too long, right? Because Hit pause if you have to. Now, I'm back. For copper, there's 1 copper and 64 grams per mole. There's 1 sulfur, it's 32 grams per mole, and there's 4 oxygens, and each one is 16. So that's another 64. You add it up, this stuff's 160 grams per mole. Now, how about the copper? Copper, excuse me, the copper makes up 64 grams out of 160 grams times 100%. So the copper makes up 40% of this stuff. Now the sulfur is only 32 grams out of 160. That's only 20%. And the oxygen, well, look at the number, 64 again, right? Same as the copper by percent by mass, not the same thing. Oxygen and copper are different, but the masses happen to be the same. And so 64 divided by 160 again times 100%, and that of course equals 100%. So what does this mean? That means if you have some of this compound, it's a white crystal powder, if you weigh out, I don't know, weigh out 10 grams. Out of those 10 grams, 4 grams would be made just of copper, 2 grams would be made just of sulfur, and 4 more grams would be made of oxygen. Well, let's change it. You have 100 grams. If you have 100 grams of this stuff, 40 grams would be made of copper, 20 grams would be sulfur, and another 40 would be oxygen. These percentages, they work for any amount. If I didn't like you, and I filled up a dump truck full of this stuff, and I dumped 5,000 pounds of it on your front yard because I wanted to kill your grass because I was in a bad mood. I'd probably kill your trees and your neighbor's trees too. But if I did that, if I put 5,000 pounds of this in your front yard with a dump truck, that would be quite a trick, right? I wish somebody should take a picture of that for the YouTube or TikTok. Like, look, who could believe this? However much I dump on your front yard, 40% of it is copper, 20% of it is sulfur, and 40% is oxygen. Now, it's all bonded together. By mass, though, if you were to decompose it and take it apart, that's what you'll get. These percentages make up what's called the percent composition by mass of copper or sulfur or oxygen of this stuff. This stuff has its molar mass, and it also has what's called percent composition by mass. So here's a math problem. We're going to do this one. You only have a pocket full of this stuff, but you don't want to destroy somebody's front yard. That would be bad. 456 grams, just a little bit more than a pound. How many grams of that pocket full of this stuff are copper? We just said it's 40% copper, right? Remember that number, 40%. Watch how I do this. We're starting with this much, 456 grams. 40%, let's turn it to a decimal. That's easy, right? 40% becomes 0.40. The whole times the proportion will give you the proportion of that whole that is this stuff. So do it in the calculator. Ready? Here we go. Clear. 456 times 0.40 equals, oh my gosh, look at that. 182.4. Look what I got. Got that one right. I'm like a chemistry teacher or something. How did I do that? I did the math. It's 40% copper. It doesn't matter how much you have. You have 456 grams. 40% of that is going to be copper. How much is going to be sulfur? How many? 456 grams. You got a whole pocket full of this stuff. How many grams is your sulfur? Well, how much did you start with? 456 grams. What is the proportion that sulfur? You write it as a decimal. 20% is 0.20. You put it in the calculator. Press the buttons. Don't look. I'm not going to make you look. Get your calculator, press the dang buttons, and make your calculator have a number, and then I'm going to go forward. I'm waiting. I'm going to put my arms like this. I'm not doing it. Do the math. Teach your fingers how to do this. Don't be lazy. I can do this. I don't need to practice. You have to. I'm waiting for you. Do the math. Press the buttons. Look at this. 91.2 grams of sulfur. So you got a pocket full, 456 grams altogether. Out of that 456 grams, how many grams of pure sulfur? 91.2. 20% of the total. Now, last one. How many grams would be just oxygen? You got 456 grams of stuff. How many grams? Well, it's 40% is oxygen, right? So how do you do that? 456 grams times the percentage written as a decimal, 0.40 again, and bada bing. Same number we got before for the copper. because the copper and the oxygen just happen, it's just a coincidence, to be 40% apiece. So we got 182.4 grams of oxygen. This is pretty cool. It's not even hard. I'm loving this. I love this stuff. All right, a little while ago, we figured this out. Water, 11% hydrogen, 89% oxygen. Think, this is a thinking question. You don't have to write anything. I don't even think you'll write anything at all here. 2 hydrogens for every oxygen. It's 2 to 1. How come it's only 11% hydrogen if it's double the hydrogen compared to oxygen? How come the percent comp by mass is 11% to 89 when it's 2 to 1? It should be different than that, right? No. How come? Because this is percent composition by mass. Hydrogens are super tiny. This is like you make a fruit salad with 2 blueberries and a cantaloupe. What's it taste like? It tastes like cantaloupe. Just a little bit of it tastes like, well, there's 2 blueberries, there's only 1 cantaloupe, but it's mostly cantaloupe. Oxygen by mass is really big compared to those 2 little baby hydrogens. This is called percent comp by mass. This is not how many do you have. We're not counting 2 to 1. We're counting 2 grams to 16 grams for the water, hydrogen, oxygen. 2 grams out of 18 versus 16 out of 18. It's by mass, and some atoms are a lot bigger than other atoms. Hydrogen's really, really little, and oxygen's not very big compared to some of the big ones, but compared to hydrogen, it's giant size. 2 blueberries, 1 cantaloupe. This is 2 hydrogens, 1 big oxygen. All right, you get a water balloon. Now, if you ever filled a water balloon up with this much water, probably about as much water that's left in my seltzer after that big gulp, 1 ml of water is equal to 1 gram, because the density of water is 1 gram per ml. It's like the only thing that has that perfect, beautiful density. There's a few other things, but that's just by chance. Water, 1 gram is 1 ml. Other stuff, 1 ml is not 1 gram. If you melted some iron, 1 ml of iron does not equal 1 gram. It weighs like 7.87. What's the density of iron? So 275 mLs of water is the same as 275 grams of water. So you got 275 grams. How many of those grams, out of 275 grams, how many are just oxygen grams? Well, you know how to do it. We just did this. Ready? Look, 89% of 275 grams of oxygen. So how do you do it? 275 grams you started with times 0.89 means out of the whole 275 grams, 245 of them are oxygen. The big number, right? Because oxygens are big and the hydrogens are like blueberries, just so little. And of course, out of the 275 grams total, 11% of that would be by mass hydrogen, 30 grams. And look, you add them up, 275 grams. The parts equal the whole. Percent composition by mass. Water is water. It's made up of hydrogen and oxygen. There's 2 hydrogens and 1 oxygen. That's the numbers of atoms. By mass, it's 89% oxygen, only 11% hydrogen, because hydrogens are little tiny atoms and oxygens are big. And because you can figure this out, 11% and 89%, doesn't matter how much water you have, 89% of all water is oxygen, and 11% of all water by mass is hydrogen. Let's see what else we got. All right, this is a cool compound. Now, this compound is funky because it's got a really cool name, right? What is the percent composition by mass of aluminum in this stuff called aluminum hydroxide monohydrate? Now, if you didn't do the COSO4 lab yet, you're not going to know what that means. So we're going to have to let's work on this formula. Aluminum is Al, and hydroxide is OH, it's a -1 ion. So when you crisscross it, you're going to need 3 hydroxides and only 1 aluminum. That's why it's Al parentheses OH 3 times. Now, this weird last word, monohydrate, some ionic compounds are attracted to water. And based upon their size and a couple other fancy things, they can attract a certain amount of water molecules around them. This is called a monohydrate. There are dihydrates. The COSO4, that's a pentahydrate. Now, we do another lab later on in the year for review. We may not do it this year because you're not really in class, but we use something called magnesium sulfate heptahydrate. And there's 12 hydrates and 10 hydrates, all different numbers of water molecules. This one happens to have 1 water molecule around it. And watch how we list this. We have aluminum, we have oxygen, we have hydrogen, and we have water as a chunk. Water. Leave the water whole because the water is not really part of the compound. It's like a separate molecule that's sticking on it. It's kind of like clothing. The person is the compound, the clothing would be the water. You could take the clothing off, you heat it up, and the water could evaporate away. So the molar mass for this stuff is 1 aluminum times 27 grams. There's 3 oxygens times 16 each, and there's 3 hydrogens. And then there's 1 water. And remember we did the molar mass of water before? I said you better remember that number, 18 grams per mole. Add it up, it's 96 grams per mole. Now, the question is about what is the percent composition by mass of aluminum? So let's figure that out. Look, it's 28.1% aluminum. Now, we could stop right here. Well, there's the answer. In fact, it's right. I know it's right because I made these slides. I did the math. But you don't know if it's right. You don't know if it'll, you have to do the whole right side and add it up and make sure you're as close to 100% as you can get. Because maybe you made a dumb mistake. Maybe this really equals 18.1. I just hit the wrong button. So you do all of them. So ready? Here comes oxygen. Okay? By mass, this stuff is 50% oxygen. And by mass, this stuff is only about 3% hydrogen. And by mass, this stuff is 18.8% water. And then what? Do the math. 100.03, that's close enough. So the answer, of course, is up on top next to aluminum. This stuff is 28.1% aluminum. You have to do the whole percent comp by mass to make sure you're really close to 100%. Right? Because if you're not really close to 100%, then, you know, then maybe you're not. You don't know. And the first thing you did, the aluminum, you're like, who knows if it's right? You have to do the math. It's not hard, but you have to do it. All right. Hey, we zipped through that class. All right. I'm starting to really love this. Now, percent comp by mass, the mass of the part divided by the mass of the whole times 100%. And guess what? On the back of the reference table, right there. See it? Percent composition by mass equals the mass of the part divided by the mass of the whole times 100%. You can use it on fruit tarts. You can use it on water, sodium chloride, copper aluminum 2 sulfate, aluminum hydroxide monohydrate, on anything. So anything, any compound. This is all connected with molar mass of atoms, molar mass of compounds, and now percent composition by mass. We're done. All right, let's turn this baby off and give you kids a break. End meeting for all.